Hello everyone. This question on board is a question carved out from the topic of converting galvanometer into ammeter. It is known that galvanometer can measure only small current of low value. It does not measure a very high current. Therefore, when we have now a high current to measure, and we need this galvanometer to measure it, then we now convert this galvanometer to ammeter by connecting a very low resistor to it in parallel. Okay, we connect a very low value of resistor in parallel with the galvanometer, and when we do that, it will now enable us to measure a very high current with the galvanometer. Look at the drawing here. We now connect a very low resistor in parallel with the galvanometer. This is the low resistor we will connect in parallel with the galvanometer. And this resistor is called shunt. It is called what? Shunt. We call it shunt, okay? So we connect shunt in parallel with the galvanometer. Look at the question. The question says a galvanometer of resistance 50 ohms, which gives a full scale deflection of 1 milliampere, 1 millimeter ampere, is to be adapted to measure current up to 5 ampere. Calculate the resistance of the resistor required. Okay. Now look at this question now. This galvanometer now, the highest current it can measure, because when we measure it, it gives a full scale deflection of 1 millimeter ampere. The highest current this galvanometer can measure is 1 millimeter ampere, and when we convert it to ampere, it is now we divide this one by 1000, and when we divide it by 1000, it will now give us 0.001 ampere. Can you see that this galvanometer here can only measure the highest value of current it can measure is 0.001 ampere, but we now need it to measure 5 ampere, which if we just ignorantly measure it, it will damage this galvanometer. Now we have to convert this galvanometer to ammeter to enable it to measure a very high current of 5 ampere. Okay. Now, then the question now say we should now calculate this shunt. It is this shunt, the value of this shunt, the question is asking us to calculate if we now want to construct the apparatus. Okay. Now the full scale value of the galvanometer is 1 ampere and the resistance of the galvanometer is 50. Then the current we need to measure is 5 amperes. Now, what is the resistor? What is the shunt we have to connect to enable this galvanometer to measure it? Now, we now use this formula, which says Rs equals to Ig Rg all over I minus Ig. Okay. Now, what does this formula represent? It is this formula we are going to calculate for this resistor needed. Okay. The formula says the Rs represent the shunt resistor we are talking about. The shunt resistor is Rs, which will be equals to the current passing through the galvanometer, which is 1 millimeter ampere, times the resistor of the galvanometer, which is 50 ohms, all over the current, the main current we now want to measure, which is 5 ampere, minus the current which passes through galvanometer. So this is the formula now. Rs represent the shunt, Ig represent the current that passed through the galvanometer, Rg represent the resistor of the galvanometer. Then the current is the one we want to measure, the main current, which is 5 ampere, minus the same current that will pass through the galvanometer. Now let us calculate this because that is what they require. Okay, We now calculate it by saying Rs equals to the current which passes through this galvanometer, which is 1 millimeter ampere, and we are going to convert it to ampere, and we divide it with 1000, which will give us 0.001 times the 50, okay, times 50, okay, all over 5, which is the main current we want to measure, minus 0.001. And when we multiply 0.001 times 50, it will now give us 0.05 all over. When we subtract 0.001 from 5, it will now give us 4.99. And when we divide the up one divided by the down one, which is now 0.01 ohms. So what is needed, the shunt resistor we need to connect to the galvanometer to enable us measure 5 ampere is 0.01 ohm. Can you see that it is a very small resistor we need? Very small to compare the resistor of the galvanometer, okay? So that if the current comes, majority of the current will pass through here, okay? Majority of pass will come through here, allowing only 1 millimeter ampere to pass. Then it is now enable us to measure this 5 ampere current, okay? Thank you so much. Please make sure you subscribe or follow me, okay? Subscribe and follow. Thank you so much for watching, and God bless.